Good morning, good afternoon, and good evening, everybody. We are here from the headquarters of the European Climatic Energy Mixes, which we'll present in a minute. This is a webinar to explore how climate may affect future European energy demand and supply with the updated Copernicus Climate Change Services ECEM demonstrator. I'm going to give a short presentation on the project itself. So the European Climatic Energy Mixes, ECEM, is part of the Copernicus Climate Change Service program. And this project, ECEM, is developing in close collaboration with the energy sector a demonstrator to assess how well different energy mixes in Europe will meet demand over different time horizons, focusing on the role that climate has on the mixes. Of course, we know that many other factors that affect energy supply and demand. What we are focusing here is the role of climate only, but as we will see, climate has a very important component and part on this energy mixes. So just a brief overview. The ECEM is composed of 4 work packages. The first one deals with the climate variables, and then the climate variables are adjusted. They are taken mostly from the reanalysis ERA interim produced by ECNWF. And then they are converted into energy variables. Sorry, there's a problem with the screen. Can I ask one of the presenters, can you see them now? Can you see it?
No, we don't. We still have the just the title and the photos.
Oh, okay. Sorry about that.
Oh, it's okay now.
Okay, sorry about that. I'll show you quickly what I showed before. So this is the start. Then this is the second slide I discussed, and now the overview of the project with the climate variables on the top left. These are adjusted, so they're not raw data from the climate reanalysis. They are converted into energy variables, into these components. Thermal power is not being considered so far, but all the others have. These variables are then used in various ways and converted into time series and other maps that are shown on the demonstrator. At the same time, we also developed case studies and other assessments of this data, which is what we are going to discuss in a minute. So this webinar is an hour and 15-minute webinar, and has 4 presentations. The first one is a short presentation to tell you about the demonstrator functionalities for the energy and climate sector. The second one will show you how the demonstrator data sets provide valuable and usable new information for the energy sector. And the third one is the new energy projections for the European domain, which has been added over the last few months. There's been a lot of work in producing all this data, as you will see once you play with the demonstrator. And finally, we have a case study, which will look at understanding changes in risk of cold, high demand winters using the ECEM projections. So you'll see the presenters and their photos. So we have Barbara Percy, first presentation, Claire, Laurent, and Emma. And I'm the chair, Alberto Troccoli. Here at the bottom, you see my picture. The presentations will be followed by a question and answer. You can type your questions on the panel that you'll see on the side. and we'll collect all the questions, put them on a slide that will be displayed at the end so everybody can see the questions. We'll also read them out, and the speakers will take turns in responding to these questions. The webinar is recorded, so later you will also be able to get back to the page of the ECEM project and listen to the recording again, except for the first part, which wasn't very good. So my part. Enjoy the webinar, and we'll now switch over to the first presenter, Barbara Percy, who is going to talk to us about the functionalities of the demonstrator. So Barbara, over to you, please.
Okay, can you see my screen?
Yes.
This is a live demonstration of the website, so hopefully things will work out fine. Never work with children, animals, and the internet, they say. But let's start with, basically, this is a quick view for those people who have not seen the website at all, the tool at all. So if I give a quick run through of the kinds of things we can do, basically, let's start at the bottom left here. This is help. We'll give you all sorts of background about the data, about how the demonstrator works, as well as things like key messages and case studies. The important bit is this control panel here on the left-hand side. Claire will explain the countries, clusters, time periods, and things like that in a moment, but some of it, like we'll explain further if you hover the mouse over them, or if you click on the question mark, it will go to a document that will give you more information. Options will change as you change selections. So if I select air temperature, we've got a change of options here. If I can change seasons, and so on. But basically, you need to make a selection for everything, and then the map gets coloured. Let's zoom out so we can see more of the whole of Europe, which means we now get a legend on the right-hand side. So the legend explains the colours on the map, naturally. It also has a slider, which you can move directly. You can go step by step, and you can play, and you can go to specific date. You can also filter it, so at the moment it goes from 79 to 2016. You can filter it to just a subset of that. There are default colours for most variables. Some of them are fixed, but most of them you can use this icon to change the colours, and that's saved as a cookie so that it will be your colour set whenever you come back to that variable again. Incidentally, I'm not showing you the URL for no reason other than the fact I wanted to make this screen as big as possible, but you can save as you make your selections in the control panel, so the URL changes, which means you can save your map as a bookmark, or you can share it by emailing it to somebody else and say, hey, take a look at this. If I hover over the map, you'll see the country name and the value and the time at which the slider is set in the legend panel. And if I click on the country, it will select it, and you can also say it's selected there, or I can change it by selecting there, or I can double click it. But selecting it means I've now got a new graph button has become enabled. It's no longer grayed out. And if I double click it or click new graph, I get a time series. What I missed to tell you is we have a download button, which means you can download the CSV for the whole date range for all the countries. And we have a download button in the graph as well, which means we can download the data that's gone in to produce this graph. We also have a graph menu where we have another download data. Now, if I add a second, I've just clicked behind the scenes here on Spain, and I can add that to the graph. Now you can see we have two graphs. Let's go for a bit more complexity. Let's add Spanish global horizontal irradiance. And you see we've got a second y-axis, so we can now add multiple areas, multiple metrics, all on the same graph. And by clicking on the legend, we can make only certain lines visible. And this is the difference between the download up here at the top and the download here on the menu, is that this menu one will only download what is showing on the graph, not the whole lot. This download will also include the French time series. The menu also gives you the opportunity to change headings, change legends, change the line colors, and naturally it gives you the option to download the image, so you could use that in your own documents. There isn't really much more to say. You can have multiple graphs. If I sneakily change to Portugal and add a new graph, we can add another graph and a further one and a further one. There's really no limit other than your own computer's memory. You quickly close all graphs, and an important little feature, at least as far as we're concerned, is the feedback form. We really would like to hear what you think about the tool, if you have any problems, if there are things that you think the demonstrator ought to be able to do and doesn't, or things that you think would be really useful to see. So on that note, I will hand over to Claire, who will give you more of the detail of the background of the variables and the data.
Excellent. Thank you very much, Barbara. And as Barbara said, we're going to switch over to Claire now. You will have noticed also that, as also Barbara mentioned, we haven't given you the website of the demonstrator. I'm sure you'll have it at hand, but one of the reasons is also we'd like you to focus on the presentations here rather than play with the demonstrator as we go. But of course, feel free to play with that if you wish. There is a lot to learn, but Claire will now walk us through what you can actually learn by using the demonstrator for a few examples. Over to you, Claire. Thank you.
Okay, thank you, Alberto, and hello, everybody. So I'm going to take 10 minutes just to give you an idea of some of the data sets in the demonstrator and what you can do with those data sets. Except my computer now seems to have frozen. Okay. Okay, so this slide provides a brief summary of the data that's currently in the demonstrator. So you can see we have climate variables covering standard climate variables like temperature and precipitation, but also variables such as radiation and wind speed at 10 and 100 meters that are more relevant for the energy sector. In terms of energy variables, we have electricity demand and hydro, solar and wind generation, and depending on the variable available as capacity factor, energy and or as power. You'll have seen from Barbara's quick introduction to the demonstrator that information is available for the country level, but there's also the option to go down to a slightly higher spatial resolution of about 100 clusters across Europe. And in terms of the time resolution, you can switch between daily, monthly, seasonal and annual time resolutions. And data is available for 3 different time frames. So historical, which is currently 1979 to 2016. We're not going to talk so much about seasonal forecasts in this webinar, but there is also season ahead assessments of seasonal forecasting skill available. And what we will focus on today is the climate projections, which go from 1979 to the middle or the end of the century. And depending on what data sets you're looking at, you can look at absolute values, anomalies, or long-term means. And as you'll see later on for the projections, we have multi-model ensemble information. The next slide summarizes some of the key characteristics of the ECEM data sets. Previous webinars have focused on how the demonstrator itself and the data sets have been developed in close collaboration with users and potential users. And also we've gone into more detail on the documentation and guidance that's available. What I want to highlight today is the consistency of the data sets. So this is in terms of consistency, in terms of the spatial and temporal scale and the coverage, the format and the underlying assumptions of the data. And that's the case if you're comparing different countries or clusters. There's consistency between different climate variables or between the different energy variables, but also between the energy and the climate. There's also consistency between the time periods. So, for example, as Laurent will explain, the same models are used to produce the energy projections as used to produce the historical energy data. And then we also have consistency across the different types of scenarios that are available within the demonstrator. So, for example, consistency between 2 different greenhouse gas emission scenarios that are included, and also between the different energy mix scenarios that are included. So what I want to do now is just show you how this consistency in terms of the data allows you to make a number of cross comparisons and explorations of the data. So the first example is an example of maps, and in this case we're looking at projections, climate change projections of radiation for spring, the ensemble mean across 7 different models on the left hand side for a present day baseline, and on the right hand side for a future 30-year period. And this is at the cluster scale, so about 100 different clusters. So we can see spatial patterns for the present day, but we can also see spatial patterns in terms of the changes. And you can also plot the precipitation projections. And if you do that and compare the 2 sets of maps, for example, you'll see that the future reduction in radiation in Northern Europe is associated with an increase in precipitation, and so more cloud cover, and this tendency towards increased radiation in Southern Europe is associated with decreased precipitation. Another way of comparing countries is in terms of time series. So in this example, I've plotted the historic winter wind capacity for the historical period, 1979 to 2016, for a number of different countries chosen fairly randomly. So this is the UK in blue at the top with the highest capacity factor values, Croatia at the bottom in red, and then a number of countries, including France, Germany, for example, clustering in the middle here. So you can compare in time series mode different countries. If you're interested in exploring a country in more detail, particularly some of the larger countries, you can look at different clusters. So this example, it's still with the winter wind capacity factor, but now I've plotted the 6 different clusters for the UK that are shown on this small map here, in time series mode here. And I was just interested to focus in on 1989, where there's some interesting differences across the UK in terms of clusters. So I've zoomed in on the map here. I've gone to 1989 to look at the map, and you can see there's high capacity values in the northern cluster and lower values to the south. As Barbara said, when you're plotting time series, you can use different left-hand and right-hand axes. You can have two different axes. So that really helps if you're exploring relationships between energy and climate variables. So in this example here, on the left-hand axis, I've plotted, this is the solar generation capacity factor for Spain for summer. So that's the time series in red. And then on the right-hand axis, I've plotted the underlying radiation data as anomalies in blue. So you can intercompare the time series, see that there's some matching of these trends, but also in terms of from season to season, the sort of troughs and the peaks are coinciding quite nicely. You can also look at the effects of climate on the energy variables in terms of longer term trends. So here, for example, in terms of the longer term projections. So this example is for Greece. The top plot is showing you the projected or the changes in annual air temperature for Greece, which you can see clearly increasing towards the end of the century. And at the bottom, you can see how that translates into, this is demand, power demand here for winter, and you can see that translates into a reduction in winter demand due to less heating, but an increase in summer demand due to increased air conditioning. And the particular plots that we have here also allow you to see differences in different greenhouse gas emission scenarios. So the orange line is a business as usual with continuing greenhouse gas emissions, compared with a scenario which has some reduction in greenhouse gas emissions. And you can see that by the middle of the century that's making some difference in terms of at least the summer demand. So the plots I'm showing you here, we're focusing on the climate effects on energy, but in other aspects of the characteristics of the data sets also allow the user to look at some of the socioeconomic influences. And this example is now going back to the historical period. So we're looking at demand, power. So this is for France over the historical period. And we have two series plotted here. So red is showing the sort of flat curve with year-to-year variability, is with the longer term trend in the demand data removed. So what we're seeing here in these fluctuations is the climate effects, but here in blue is with the longer term socioeconomic trends, so increase in energy demand, flattening out around about 2007-8. So this is seeing the influences of sort of socioeconomic conditions. And in the next presentation, Laurent will show how you can also explore different energy mix scenarios for the future, as well as taking into account the climate projections. So that was a few very quick examples, but hopefully giving you some feel for how the data in the demonstrator can allow you to explore relationships between climate and energy, both over the last 40 years, and how these relationships might change over the coming decades. As I said, what we haven't covered today is seasonal forecast, but you can go and play with that data yourself. So all the time series plots and graphs that I included in my presentation were downloaded directly from the demonstrator using the buttons that Barbara mentioned. So you can do the same thing and import time series plots graphs into your own presentations. The other thing, as Barbara mentioned, you can do that the underlying data can be downloaded. So that gives you the option to undertake your own more detailed analysis using your own software and models and maybe bringing in your own data. So thank you.
Okay, thank you very much, Claire. It was clear and to the point presentation. So it's setting the scene for now the next talk by Laurent, who's going to tell us in more detail what how the energy data have been produced and how they're displayed and how they're used. Over to you, Laurent, please, for your presentation. And just a reminder, you can type questions at any time on a panel on the side, and we'll collect them for the end. We'll answer them all at the end. Thank you very much. Over to you, Laurent.
Okay, thank you. Can you see my screen?
Yes, yeah, all fine.
Okay. Okay, good morning, everyone. So I'm indeed going to give you some details about how the energy projections were built and show some additional examples after Claire's presentation. So the outline of the talk will be just a few reminders and some basic elements about the energy models that were already presented in a previous webinar. And then I will explain briefly what assumptions we made for the energy projections, and then show you some additional examples and how you can use this to make particular studies. So just about the energy models, I can just insist on the fact that the models have been set up and calibrated on the historical period. So they are based on climate data produced in the work package 2 of the project. So these have been bias adjusted. And then we use energy data, mainly from the ENTSO-E, so the European Association of Transmission System Operators. And we built either physical or statistical models, depending on the available data, to simulate the energy variables on long periods. So the models were built on the past, on the run analysis period from 1979 to 2016. And then these models were used again for the long-term climate projections, which I will briefly present today. So just to remind you, I won't go into the details because this was presented in a previous webinar on the 20th of November. So you can go on the website to see more details about that. But for instance, for demand models, we built individual models for 32 countries, except Albania, because we didn't have the data available at that time. It is now, so it will be included probably in the future. And for demand, we use generalized additive models, so statistical models, based on temperature, global irradiance, relative humidity, and wind speed at 10 meters. You have some validation plots presented here, but I won't go into the details today. For solar power, we use the physical model because we have one which was developed especially by our colleagues from Armin. And in this case, we use only global horizontal irradiance and temperature at 2 meters. You have a validation plot for Germany, for instance, over the historical period, which shows that the model is very good and very accurate, with a high correlation and very little bias. For wind energy, we use 2 different approaches. One with a very simplified physical model, in which we considered we had the same type of wind turbine installed everywhere in Europe. And we also use statistical models for the countries where we had data available to build and calibrate those models. There are differences between these two and with other projects as well. Once again, I won't go into the details, but it was just to mention that we have different possible approaches. For hydropower, which was probably the main difficult part of the energy models, because we don't have a lot of data for hydropower, and basically the idea was to use physical models for each important hydropower plant in Europe. But for doing that, you need both the location of that plant and their characteristics, which means the installed capacity and the hydro ricket, for instance. Fortunately, such a database doesn't exist for the whole of Europe, and in countries where it exists, it's in general considered as confidential, and it's very difficult to get this kind of data. So we used very simplified models using only country average temperature and precipitation and some lag variables. Once again, I won't go into the details. And for runoff hydropower production, it gave quite good results. It was a little less good for reservoirs, but it gave some results. So clearly, this is the area where the strongest improvement can be expected in the future. I will now give some details about the assumptions for the energy projection. Sorry, I still have a cold. So as said before, we use the historical period to set up the models. And from then, we use the climate projections from the different models. So we have 7 climate models and 2 emission scenarios, RCP 4.5 and 8.5. And from these, we can apply directly the energy models to compute the energy demand anomalies up to 2050, or even 2100. And in the same way, we can compute the wind, solar, and hydro capacity factors to 2100 as well. But when we want to compute either power or energy variables, so megawatts or megawatt hours, we need to make some assumptions on the installed capacity of wind, solar, and hydro, for instance. And the choice we made in the project was to use the EIWay 2050 scenarios. So EIWay 2050 was a former project, H2020 project, which designed different scenarios, 5 in fact, for different energy mixes in Europe by 2050 in order to study the needs for the networks, reinforcements, and so on. So the basic scenarios are described on the bottom panel. You can see that they are very, very different, one from each other. This plot shows basically how demand and installed capacity vary between those different scenarios. Overall, you can see that demand is increasing for all of them with respect to the value in 2013. But of course, it varies in the shape and in the use of electricity which is made in each scenario. And for generation as well, we have very different features, some of them being based on, let's say, old fossil fuels, some of them being very optimistic in the development of renewables. You can find all this information on the EIWay website, on which you will find a very nice booklet which summarizes the project. So when we have for instance, the capacity factor for wind, solar, and hydro, and that we want to convert that into energy, so instantaneous power or energy produced by those means of production, we need to make hypothesis on the installed capacity. Unfortunately, in EIWay 2050, we have these installed capacities for the 5 scenarios and the mean demand levels as well, only as one value for 2040, one for 2050, so for each of the scenarios, all these starting from the actual ENSOE 2014 values. So the assumptions we made was to interpolate linearly those values from 2014 to 2040-50 to get the daily time series of installed capacity and mean demand levels. So you can see, for instance, on the top for France and Germany, those linear interpolation of wind power installed capacity for the different scenarios. So the color codes are the same than for the EIWay scenarios. Of course, you can see and say that this kind of interpolation is quite dirty. It has some strong steps which are not very nice to see. Unfortunately, that's all what we can do because we don't have any other values between 2014 and 4050. In the next phase of these Copernicus energy activities, new scenarios will be available, which provide information every 5 years to 2050. So it would be probably cleaner in this sense. So just a few examples of the energy projections now. First, I've plotted here an example for France, so it's about demand. On the blue and the reddish colors, you can see what Claire presented just before. So it's the detrended in red and full signal in blue for demand above France over the historical period, which end here at the black bar. And then I also plotted the detrended climate projections to 2065 in green. So this is the only the climate part of the signal, if you wish. And in orange, you have what it would give, considering the scenario number 1 from EIOS. So number 1 is sorry, I must come back. It's big and market, but whatever, it doesn't mind here for the explanation. So the green is only the climate part of the signal, and the orange is what you get if you consider this variability added to the mean level of demand, which is anticipated by the EIOS scenario. Of course, you can, on the plots on the demonstrator, I won't go interactively into the website because it would be too long for now. But you can also plot the scenario number 2, 3, 4, 5, and so on. You can also mix the RCPs. So looking at RCP 4.5 and 8.5 and so on, and so the differences between all these scenarios. You can also plot and compare, as Claire showed also, the same curve for different countries. So here we have the anomaly demand for 4 different countries: France, Spain, UK, and Germany, for one given emission scenario. And so on and so forth. You can go into finer analysis. Here is an example for Spain, which is similar to what Claire showed for Greece just before. So in blue, you have the winter anomaly demand for Spain, and in red, you have the summer anomaly demand for Spain. And you can see that with the increasing temperatures in the future, there will be a reduction in consumption for Spain in winter and an increase in summer due to, of course, cooling needs. We can also plot what we call the full plots, which try to summarize all the possible evolutions for one given variable. So it's here again. Sorry, it's again so the normalized anomaly for demand in France. And you have the scenarios 8.5 and 4.5, so in different colors, brownish or bluish, in which you have all the scenarios, which are the thin lines. The thick lines are the ensemble means, so the mean of all the 7 models. And in shaded areas behind, you have the smoothed minimum and maximum of the evolution. And for instance, if you plot this kind of full plots for all countries for demand, you will see more or less the same future with a decrease in energy consumption by 2050 and beyond. Another example of a full plot is the wind power capacity factor for Germany. And here you can see that there's almost no trend, or at least it's not visible by eye. And in addition, there is no significant difference between the 2 emission scenarios, so scenario 8.5 and 4.5. An additional one is for wind capacity factor. In this case, I just plotted the red curve is scenario 8.5 for Germany on the left. And it's the ensemble mean, so the mean of the 7 scenarios, of the 7 models, sorry, with the smoothed mean and max of all the ensembles in shaded, in pink shaded. And superimposed on that, you have the 2 different models we set up on the historical period. So the dark pink and the green, which are the 2 models. So there's one which is a statistical model in pink, and the physical model in green. So you can see that both those models have some differences, but more or less they agree quite well. And that on the historical periods, the ensemble of models which was started in 1979 as well, reproduce quite well the behavior of the observed wind capacity factor. But for example, on another country, on France, you can see that for the same plot that the climate models have apparently some difficulties in representing the capacity factor, because we have a much lower level than what is observed on this period, and this probably means that the wind speed over France is too weak in the climate simulations. So as a summary, the models we use for the projections have been built over the historical period, and we have some good elements of validation for those models. The power and energy values are clearly dependent on the assumptions we made on installed capacity. Remember this linear interpolation from only 3 values from 2014, 40, and 50, which of course is probably a weakness of the process because of the shape of those interpolations. But the important point is that the demand anomalies and the generation capacity factors are independent of these assumptions, and so we are quite confident that this is a very good approach, and it gives some good projections of those parameters for the future. Of course, as a limitation, our dataset doesn't take into account any technology changes. For instance, we considered in the wind model, we use the same wind turbine type, which is a Vestas V 110 2000 megawatts, both for the historical period and the future, which is not relevant because turbine types do evolve in time, and so new turbines in the future will be probably more powerful and so on. But this approach allows to clearly simulate what climate change will have as an impact on energy demand and supply, everything else being equal on the other aspects. The main signals we can see so far is essentially a decrease in winter energy consumption and an increase in summer energy consumption, which is expected due to the increase in temperatures, both in winter and summer. There's not much signal on solar and wind power generation. I didn't see anything about hydropower there, but we see some signal on hydropower, especially between the northern and southern countries, so Norway and Spain, for instance. And so even if we are less confident in hydropower projections due to the real simplification of the projections, we think there's some expectable signals and things which can be looked at there. And for now, what can I say about that? I want to remind you that this is a proof of concept, so you need to read carefully the documentation to make sure you're fully aware of the limitations and you don't make misleading use of the data. But you can use the demonstrator and download the data. And as Barbara said at the beginning of this session, please give us your feedback and report an issue you may find. We think there are still probably some issues, but I think we fixed most of them. But essential is your feedback to improve the presentation of the service and so on. And you need to know that there will be an operational phase of this Copernicus Climate Change Service energy product, which will be developed in the next 2 years. And the last point is that we'll have opportunities to interact directly during our final symposium, which will be held in beginning of March in Paris. And with that, I will like to leave the floor to Emma. Thank you.
Okay, thank you very much, Laurent. That was a great presentation of all the work that has been done on the energy side for the energy variables. As you can imagine, there's been a huge amount of work to produce all this. And although Laurent is keen, as we all are, to highlight the fact that this is a proof of concept, it shouldn't be underestimated all the work that has gone into producing the wealth of data that is being displayed here. So please have a go at it and let us know what you think, as has been repeated already. And now we're going to show you how the data are used for kind of mock-up study in the sense that we assume some conditions for certain cases and see how the data can be used to address those cases. So Emma is going to discuss this next. Please, over to you.
Thank you. So yeah, I'm just going to walk you through an example of a particular case study that I've been thinking about. It relates to understanding changes in risk of cold temperatures and high demand winters using the underlying demonstrator and using the ECEM demonstrator and its underlying data sets. So this work forms part of a wider set of case study documents trying to illustrate basically how you would use the demonstrator and the underlying data to sort of tell a story and to understand risks from your perspective, essentially. So the motivation basically for the case study documents, as I've just said, is to try and help illustrate how we can get best use out of the ECEM demonstrator tool and the underlying data itself, how you can use the tool to sort of to create a story and a picture for a particular question that you might be interested in. So it might relate to low temperature, high demand events in a particular country, or it might relate to how you might understand the risks into the future. So we'll look today at so these low temperature, high demand events, particularly thinking about the historical case of the winter 2009-10 over the UK and over France and over Northern Europe, and how we might understand that event going forward into the future. So how the risk of an event like that might change with the future projections of climate and of the energy mixes going forward. So the second motivation basically is to try and understand risks, as I said, so thinking about the actual underlying data that's on the demonstrator. So you can download the data, you can do your own analysis on it, you can put it into something like Excel or into another programming tool, and you can start to really explore variability. You can start to explore covariability between different data sets and between different countries, for example. And there's a running theme throughout all of these case studies that relate to understanding variability. There'll be one on seasonal forecasting, which we won't discuss today, and then understanding future risks using the climate projections. So as I said, these particular documents, there'll be 4 of them that are developed through this project relating to various different events that will all appear as a document on the ECEM demonstrator. So you can go to those, you can download the case study documents, and you can use them as ideas, templates, if you like, to generate your own case studies using the demonstrator and the data that's on there. So as I said, so we're going to just look, I'm going to walk you through an example using cold temperature, high demand winters. So looking into at the past, looking at those events, and then at the future projections as well. So just to give you a couple of headlines before we explore the data and look at some of the data from the demonstrator. So you can use this information to sort of to boost your own decision making. So for example, we can see from the demonstrator that in winter there might be fewer temperature related peak demand events. We might be able to look at the fact that the sensitivity of the power system as a whole to weather becomes more important as renewables generation increases, and we might be able to say something about the likelihood of low wind winters in future. It looks like they might be similar going into the future as they have been in the past. So actually, as we get more renewables on the system, we then become more and more vulnerable to those low wind situations. So let's just look at a particular event in a historical context. So on the left-hand panel here, we have demand time series, seasonal demand time series. So in the winter period for both the UK and for France. Now we can see obviously the demand over the historical period is generally going up until we hit about 2008, 2009, and then that demand starts to level off. But in both cases, in France and over the UK, we see a peak in demand for this winter 2009-10. So at that point, 2009-10, it was the highest demand event that was seen. Obviously, there's another peak beyond that, but we're just looking up to that point for now. Or we can also see that, oops. So we can see that the day-to-day fluctuations are pretty high. So if we look in terms of anomalies, so differences from the norm, we see that demand was sort of unusually high over that whole winter period from a day-to-day standpoint. That coincided with a particularly cold winter period. So we can see the map on the left here, cold temperatures in the north of Europe, slightly warmer than normal. So this is compared to the average compared to normal winter temperatures. So it was a particularly cold in the north of Europe, warmer in southern Europe. And that's consistent with a large scale pattern called the North Atlantic Oscillation. It's consistent with a long prolonged phase, negative phase of the North Atlantic Oscillation, which leads to this north-south divide within temperatures. And so we can see that in the UK in particular, it was one of the coldest winters on record up to that point, so over that historical period. And we know that temperature and demand are related to each other. So the cold temperatures are the thing that was driving the high demand at that point of time. We can also start to look at events like this and say, okay, well, what if that particular winter happened today? So using the historical data set, if we look, for example, at wind power capacity factors, we can look at what would the wind capacity factor have been based on the historical temperature and historical wind speed values. And we see that in 2009-10, if that winter happened today, then we would have a significant drop in wind power capacity factor. And obviously, as the installed capacity of wind power increases over time, we might become more and more sensitive to a situation like that. So this negative phase of the North Atlantic Oscillation leads to cold temperatures, also leads to still low wind winters. So in this case, we would be looking at a risk of a very low wind power generation over the winter period. So we can also start to ask, can we anticipate those kinds of winters going into the future? And this is using the climate projections. So the graph here is looking at, this is the full plot of climate projections going up to 2100, using all 7 of the climate models that are available and the 2 emission scenarios that were talked about earlier. So again, the blue is RCP 4.5, so a sort of a slight reduction in greenhouse gas emissions, whereas the orange is a more business as usual type scenario. And we can see that in both cases, this is for temperature, that going out into the future, all models suggest, so again, this is just for the UK now, all models are suggesting that temperatures are likely to rise in the winter. So there is an upward trend, quite a clear upward trend in temperatures for both scenarios going out into the future. So the black line and the red line here are just a set of historical observations. And we can see again, so there was this sort of a peak or trough at 2009-10, where that was that coldest winter that happened. So although we can see that in general temperatures are rising for the winter, there are still model cases where the models do reach very low temperatures. So there is still a possibility that we could get a cold winter. It's just that general average temperature is looking likely to increase. So that might say something about what we might expect for demand going forward into the future. So if we look at the demand then, we can see that there's a distinct downward trend in demand moving into the future. There's not such a clear difference between the 2 emission scenarios at this point in time, but there is definitely a clear downwards trend. And we also see that there are some significant spikes in the demand time series from individual models. So it's still possible that we will get these demand peaks. It's just that the average winter level of demand looks like it's shifting downwards. If we look at what that might say for wind and then wind power, so if we look at the wind power capacity factor moving forward into the future, we see that there are no trends. So there's no upward or downward shift in the likelihood of these still winters that coincide with the cold temperatures. So it's still possible and still quite likely that we might get very low wind winters moving forward into the future, and there's no trend that says they will become more or less likely. So again, we see here that the observations show this sharp dip for 2009-10, which looks like it was very unusual. But we also see other dips in wind power capacity factor as well. So those things are still likely, which lead to a risk for wind power generation. Okay, so if we look at the e-highway scenarios, which are basically one set of scenarios for future energy mixes. So on the right-hand side, Laurent showed this figure earlier about the differences between each of the energy mix scenarios. And we can see what that means. So I've tried to make the colors the same on the left and right-hand panels. We can see what that means for actual wind power generation over the UK compared to the different scenarios, so that we see different scenarios lead to a sharp rise in wind power capacity, wind power production over the UK in the winter. But there's also, you'll note, quite a lot more variability in the wind power production in the higher scenarios compared to the lower scenarios. So while the general patterns may be clear from these individual scenarios, actually what we're interested in as well is understanding how the year-to-year variability or season-to-season variability in wind power might change. So as we increase the amount of renewables on the system, we become more and more sensitive to this variability in wind speeds, and then consequently in wind power generation. So that becomes an important factor. So that's just giving you a brief overview of how we might use the demonstrator to sort of tell a story, and in that case, looking at cold temperature, low wind scenarios. There are a bunch of other case studies that are either on or being prepared for the demonstrator right now. One relates to the historical outlook of the winter 2009-10 event. The one I've just spoken to you about is the climate projections of cold, still winters. There will be one coming on seasonal forecasting and as well on the Spanish heatwave of 2015, as well as a more technical document on understanding various aspects of variability. But the idea basically of these case studies is to generate ideas for you so that you can start to think about how you might use the data to answer the questions that you're interested in, how you might be able to go and do that, and actually just start generating your own case studies. So I think that's it from me. Thank you.
Excellent. Thank you very much, Emma. That was a very clear run through one of the case studies. As Emma said, there are others that will appear later in the project. The project is actually going to finish in the near future. So we currently trying to extend it by 2 months. So they should finish in March. So the end is closed, but we're still collecting ideas, feedback, and trying to put all the feedback we received back into the demonstrator, the data, and obviously if we find issues and bugs, we'll fix them as soon as we can once they observed. So we said that we were collecting questions. We received a few questions from you, the audience, and thank you very much for submitting those questions. So I'm now showing them. I think you can see them on the screen, as well as the demonstrator website that I'm showing here, as well as in a couple of slides later. In terms of questions now, we are going to go through one by one. Some of them have been addressed as we were talking, but there's maybe some aspects that need to be clarified still. So I would like to ask our speakers to address some of the questions. So the first one, perhaps Laurent would like to address this one. What is the Highway 2050? Is it based on population weighting? Would you like to respond to this, Laurent?
Yes. By the way, we don't see your slides at all. We are on the other black screen now.
Okay.
Yeah, Highway 2050 was indeed based on different assumptions. So population is included into that based on the European Commission projections, so based on Eurostat data. But not only, there are also projections of economical scenarios and so on. They explored, I think, much more than 5 scenarios initially, but they ended up with this ones. And so yes, population density and its evolution in the future has been taken into account. And more details can be found on the EAWE website or on the summary booklet, which is very well done.
Okay, thank you. Can you see the screen now, Laurent?
Still not. It's always black.
Oh, okay. I'm sorry about the issue. Maybe now. Okay, sorry. Yeah, it's a pain with GoToWebinar. You need to dismiss each attendee one by one. I don't know if there is a better way to do it. Anyway, yeah, there's someone trying to get back again. Okay, no, I think it's fine. I don't know if there's any. I think it went very well.
No, there were just some issues with your slide at the end. It stayed frozen on the questions. We didn't see the symposium announcement and so on.
Oh, really?
Yeah.
Oh, cool.
I think it was the same for Claire. Yeah, she sent a message. She had the same problem.
Oh, I don't know what happened in this. Oh, okay. It's really annoying.
Yeah, anyway, people will have the information on the website. So.
Yeah, I can see it now.
Yeah, no, it's okay.
Okay. Anyway, I'll upload. We'll upload the presentations now. I'll pass them to Leslie for upload. Okay. Anyway, yeah, we had very good attendance. Reasonable questions. Any more? No.
No, nothing on my side. I think. Sorry, I was 3 minutes too long.
Oh, it's okay. Yeah, we all went a couple of minutes over. So it's, okay. Thank you, and we'll be in touch soon on other matters.
Yeah. Okay.
Okay.
Bye, everyone. Have a nice day.
Bye.
Bye.
And you. Bye-bye. Thanks.